Hi, I'm Eric Combs with the Sound Beginnings series, and you're watching part 3 of a 3-part series on teaching rhythm. Part 1 of the series was just a theoretical explanation of how this whole system works. Part 2, we dived into David Newell's book, Teaching Rhythm, and we went into my classroom and we saw just how this teaching approach works with a beginner band as I taught them how to play 16th notes for the first time. And once the group learns to fluently read these rhythms, we move on to the next part, which is teaching them the theory behind the rhythms. And that's where part 3 of this series comes in. We're going to talk about teaching theory of rhythms to students. We're going to use a book by David Newell called The Simple Rhythmatician. This book is available through the Chose Company, and it works much like a method book. It's a supplemental material book, and it focuses just 100% on rhythms. The notes that it uses are very simple, and it just dives into talking about rhythmic theory. There are some very unique ideas in this book, and it's based on teaching rhythms with the whole note being the fundamental. And we're used to teaching whole notes as being 4 counts to our students. But this book kind of explores the option of having whole notes equal to something other than 4. And it really helps the kids to wrap their minds around how these rhythms work. One really cool part about this is it gets the students playing in 6/8 and cut time almost immediately with very little explanation from the teacher, and it makes sense to them. Let's open this up and see what's inside. First thing we come to is something that's very fundamental, but we're going to see that it's presented in a way that may challenge some of our current teaching methods. The book starts off very simply with a picture of a whole note, and it says that that picture is a whole note. It is the head of an entire family of notes and is the most important of all notes in music. Next, we learn that there are 2 important things to know about whole notes. Number 1, they are always called whole notes. That will never change. No matter how many counts they get, the name stays the same. And secondly, whole notes can receive any number of counts, and that's actually the basis of this entire book. It goes on to tell us that although you are probably most familiar with 4-count whole notes, much music is written in which whole notes do not get 4 counts. To introduce you to this kind of music, we're going to have some fun. In the exercises that follow, look inside the big blue whole note to see how many counts to give the notes in each exercise. So for most of the exercises in this book, you're going to see on the left-hand side of the exercise a big blue whole note, and it's going to tell you what the whole note value is for that particular song. And it's going to vary. It's not always going to be 4. Sometimes it'll be 4, but sometimes it'll be something like 7, 1, 5, or 2, or any random number. If you look at example number 4, you might recognize that this is actually cut time. Now the students don't know that yet, and we're going to hold off telling them that, and they're going to kind of figure that out on their own as they go along, and you'll see that happen. We're first going to look at exercise number 1. You'll see to the left of exercise number 1 that the whole note equals 7. What we're going to do is listen to my 7th and 8th grade band, which is my 2nd and 3rd year players, and they're going to play this for you so that you can see what that example sounds like. 1, 2, ready, play. Now, as you can see, the band's going to do the exact same set of notes, same pitches, several times with different whole note values. We just did it with 7. They can do it with 1. They can do it with 5. They can do it with 2, any random number. I'm going to demonstrate what happens whenever we do it with whole note equals 1. 1, 2, ready, play. Next, the book talks about ties and how ties work. And it's going to show us that if you have a whole note equal 3, that's going to equal 6 whenever you tie it all together. The band's actually going to try this. We're going to try number 6. We're using 1 count whole notes now. So you'll hear that played for 2. 1, 1, 2, 2. Let's hear what that sounds like. 1, 2, ready, play. After explaining ties, the book goes on to explain whole rests. It says that whole notes and whole rests get the same number of counts as each other. You're now going to hear the band play number 8, where the whole note equals 3, and we will have a whole rest that is also 3. 1, 2, ready, play. Here's a neat little piece that we can play using just whole notes and ties where the whole note equals 1/2. Now the kids have to think about this for a moment. If a whole note equals 1/2, how long does that mean that these are going to sound? Take a look at this for just a moment and figure it out on your own, just like your kids are going to have to. Time's up. Let's see what it sounds like. 1, 2, ready, play. The book now goes on to talk about half notes. It shows what a half note looks like, and it says that half notes are always called half notes. That'll never change. But the amount will change based on the whole note. They are always 1/2 of a whole note. So, if a whole note equals 4, the half note's 2. If the whole note's 8, the half note's 4. If the whole note's 20, the half note's going to be 10. The band's going to play their first song that uses half notes. We see that the whole note is 6, so we know that the half note's going to be 3. The song is all half notes till the end, until we have a whole note there at the end. And let's listen and see what this sounds like. 1, 2, ready, play. This is pretty exciting because we're about to do 17, and this is cut time. We don't tell the kids this is cut time quite yet, but they're able to understand it pretty easily. Whole note equals 2, therefore half note equals 1. Let's see what this sounds like. 1, 2, ready, play. We now move along in the book to learn about quarter notes. We learn what they look like, and we learn that there are 2 very important things to know about quarter notes. Number 1, they are always called quarter notes. That will never change. No matter how many counts they get, the name stays the same. Number 2, quarter notes receive 1/2 as many counts as half notes. Half of a half is a quarter. And I like the little visual they give here of a whole American football game, like a whole note. The 2 halves, like half notes. And then each half is divided into 2 quarters. So you have 4 quarters in a whole. And then there's a little bit of math here. For instance, if a whole note equals 100, a half note equals 50, a quarter note equals 25. We also learned the rhythmatician chant. It says that when whole note equals 12, say whole, half, quarter, 12, 6, 3. We're going to move on and do number 33. Listen to the band play as they play this song with whole note equaling 8. And as a group, we would say whole, half, quarter, 8, 4, 2.
Whole, half, quarter, 8, 4, 2.
Ready, play. Number 37 here is very interesting. We have whole note equals 2. We'd have the band say whole, half, quarter, 2, 1, 1 half. Think about that one for a second. Now let's see what it sounds like.
Whole, half, quarter, 2, 1,
1 half. Ready, play. That last song was in cut time. Now we're going to move on to eighth notes. I kind of skipped over a part in the book where they talked about quarter rests, but you get the idea on that. Eighth notes talks about what they look like, and as it says for all the other ones, there's important things you need to know. They're always called eighth notes. Name always stays the same. They receive 1 half as many counts as quarter notes, and half of a quarter is an eighth. We have another visual. And our math is broken down even farther. Whole note equals 80, and the half note equals 40, quarter equals 20, eighth equals 10. What we're going to do now is move on to number 61. And what we're going to say here is whole, half, quarter, eighth. 8, 4, 2, 1. So each one of these is going to receive 1 count.
Whole, half, quarter, eighth. 8, 4, 2, 1.
Ready, play. Occasionally, David Newell sticks one in here like this where the whole note equals 4. That's a novel idea.
Whole, half, quarter, eighth. 4, 2, 1.
1 half. Ready, play. Here at number 81 is yet another example of where we have cut time. It's not explained to the kids as cut time quite yet, but they do know that each one of the whole notes equals 2, therefore the half notes equal 1, and the quarter notes equal 1 half.
Whole, half, quarter, 2, 1.
1 half, ready, play. The book then moves on to 16th notes. You know the drill by now. It gives you all the information that we've had for all the other notes and the math involved in it. And I'm just going to jump right ahead to number 85 here. And this is pretty cool how this works. We have whole note, half note, quarter, eighth, 16th, 16, 8, 4, 2, 1.
Whole, half, quarter, eighth. 16, 16, 8, 4, 2, 1.
Ready, play. next little blurb. The title of the book is The Simple Rhythmician. In the title, the word simple has multiple meanings. First of all, the obvious one is the fact that reading rhythms is simple. And this book goes out to prove that. Also, the examples in the book are simple. More importantly, though, all of the examples in the book are in simple meter. So whenever we have 3/8 notes in a measure, we're reading in 3/8 simple meter time, where each eighth note gets a beat. I'd like to point out that Mr. Newell is already in the process of thinking about another work called The Compound Rhythmician, where he shows us that reading compound meter is also simple. I'm excited to say that I've seen the initial draft of this, and some of his initial ideas is pretty genius as well. This next exercise is one of my favorite ones in the book. The whole note equals 8. Therefore, each one of these eighth note is going to be 1 beat long. If we were to put a time signature on this, it would be 3/8. Now, you've probably spent quite a bit of time in class before trying to explain 3/8 or 6/8 or 12/8 to the kids, and a lot of times we confuse them just because of all of the explanation that we use. The beauty of this is the way that the book has set it up. We don't really have to explain it. All we have to do is tell the kids that the whole note equals 8, and they go ahead and they play it on their own. So the book really gets them playing in simple 6/8, 12/8 meter, and 3/8 meter pretty quickly.
Whole, half, quarter, eighth, 16th, 8, 4, 2, 1, 1/2.
Ready, play! This one here is really cool. Whole note equals 8. I want you to take a look at that for a second. Try to figure out on your own what that would sound like. And now let's listen to it.
Whole, half, quarter, eighth, 16th, 8, 4, 2, 1, 1/2.
Ready, go! The book then moves on to dotted notes, and it does so very simply. It says, placing dots after the notes in music's family of notes results in a new, closely related family that we call the family of dotted notes. Then this little box is important. When a dot is placed after any note, the note becomes longer by 1/2. For example, a dot after a 4-count note adds 2 counts to the note because half of 4 is 2. Then I like this. There's a little page of dot math, they call it, where you can add up how much each of these will be after you put a dot next to it. Then we're going to jump on over and do some exercises with dots. In fact, this would normally be complicated anywhere else, but it's actually fairly simple here. Whole note equals 8, and we're doing some dots. Basically, the kids are playing in 6/8 right now. There's no time signature there to say it, but that's what this is.
Whole, half, quarter, eighth, 8, 4, 2, 1.
Ready, play! There's a lengthy page here that's explaining dotted notes, and it's actually really useful. The thing that I find most helpful is this little saying right here that says to step on the dot. I love that. I will say that I used to have so many problems teaching dotted notes to kids until I started doing David Newell's method. And first you do what I showed you in video number 2 with the classroom demonstration and learning it sound before sight. And after they can do that, you can really explain it with this step on the dot, meaning that you're going to step on count 2 with a dotted quarter note before moving on to the next note. And there's several step on the dot songs in here. In fact, one of them is number 92, or I'm sorry, number 107 right here. And the kids know these songs.
Whole, half, quarter, eighth, 4, 2, 1, 1/2.
Ready, go! This is the point in the book where it is absolutely pure genius, and I would have never thought about it this way, but David Newell really leads up to it really well. Talks about what a time signature is. After all this work talking about whole notes of different lengths, we talk about a time signature, starting with the bottom number. And David tells us that the bottom number is simply how many beats a whole note gets. Now this is just really cool. Instead of putting the blue circle over here that says whole note equals 2, we're just saying that since there's a 2 down at the bottom of this key time signature, that whole note equals 2. It's cut time.
Whole, half, quarter, 2, 1, 1/2.
Ready, play! Finally, we talk about the top number. The top number of the time signature simply tells us how many counts will be in each full measure of music in the piece. When the time signature is 4/4, we know that the total number of counts in each full measure will be 4 based on the whole note value of 4. Then it's going to go on to provide some more theory. I really like this. The band plays these songs and they have to tell you what the top number should be for each one of these. We talk about 2 non-number time signatures and what they equal. So now we know finally what cut time is, theoretically. We talk about changing time signatures, and we do some pieces where we have to change back and forth between different time signatures. There's some worksheets, and at the end there are some final songs. I'm going to leave you with one final song here.
Whole, half, quarter, eighth, 8, 4, 2, 1.
Ready, play! That concludes part 3 and the series on teaching rhythm. I highly recommend using the book by David Newell that was just shown in this video. Again, I use it with my bands every single year. It's meant to be done in just a couple of exercises a day, but it really does help kids to learn how to fluently understand the theory behind rhythms. I also would like to point out that this book should not be done until after the events of video 2. Thanks for watching.